This is a video for Algebra 1 Summer School, Unit 4, Lesson 4, Exponential Models with Percent Change Practice. I'm going to start with number 2 at the top of the page, where it says, using the given starting value of percent change, write an exponential model. All right, so we're told that we want our model to start at 100 with a percent increase of 90%. Remember that exponential models are of the general form y equals a times b to the x. A is always our starting value. So in this equation, we want our starting value to be 100. Now I have a percent increase of 90%. So when I do percent increase, it says right up above that we take 1 plus the percent, which is 0.90, to the x power. If you want to rewrite this, you could write that as y equals 100 times 1.9 to the x, if you wanted to simplify the 1 plus 0.9. All right, the next problem that I'm going to do is number 5, where you're given the model and then you have to state the starting value, whether the exponential function is increasing or decreasing, and what the percent changes. For this model, we're told p of t equals 25 times 0.6 to the t power. Our starting value is the first number that shows up in our equation, which is 25 here. Now, because 0.6 is less than 1, we know that this exponential model is going to be decreasing. We need to figure out the percent change, though. So we talked in the notes about how if you're going to have a percent decrease, to find the change, you take 1 minus the value in the parentheses. Well, 1 minus 0.6 is 0.4, which is a 40% decrease. Okay, the next problem I'm going to do is the very first multiple choice problem on the page. It's right below. It says, which of the following models represents a percent decay by 21%? Well, the first thing I would do is cross off any answers that are percent increase. Like, for example, letter A is 1.21. That's exponential increase. We're looking for decay, so we're going to go ahead and cross that off. Same with C. 1.79 means my model is increasing, which I do not want. So in order to have a percent decay, I'm left between choice B and choice D. Think about if you were to write this model, the percent part in parentheses, you would write as 1 minus 0.21. Well, neither one of B or D look exactly like that, as 1 minus 0.21. But if I put 1 minus 0.21 in my calculator, I would end up with 0.79. That looks just like the growth rate in D, which is indeed the correct answer here. So you have to be really careful that for percent decrease, you have to take 1 minus the percent, not just stick the 21% in the parentheses. All right, the last problem I'm going to do is under the mixed review part. We're going to do number 2. This is an exponential function, 29 times 3 to the x. Just like we did above, the starting value here is 29. Now, when I look at the growth rate here is 3. 3 is definitely a value that's bigger than 1, so this is going to be exponential increase. I don't have a percent this time, though. It's not 1.5 or 1.98. It's just 3. So it's just our growth rate is 3. We call that tripling. All right, so those are the 4 problems that I'm going to do for you on this practice. If you have questions on the other part of the exponential models with percent change, check out the answer key that's posted on Canvas, or stop into office hours and ask your instructor.